everyone. My name is Glen. You can find me on Twitter and on GitHub, and I'm going to be talking to you today about some work we did at CircleCI. Now, to kind of set the scene, give you some background, I am a huge fan of Honeycomb. I've really drunk the Kool-Aid, and I found it really seemed to fill a gap I was experiencing with my existing tools. And I can imagine if you're watching this talk, then I suspect you're also hooked. And what you're hooked on, or likely to be hooked on, is seeing trace graphs like this. This sort of insight into what's going on inside applications seems to be driving a lot of Honeycomb adoption. But more importantly, also a lot of application improvements as we look at these graphs and go, my application's doing what? And then go ahead and fix it. And as our application architectures get increasingly Byzantine, people are crying out for better insight into what's going on in and across their systems. As we create these huge microservice architectures with hundreds or maybe even thousands of services in some cases, and we'll often end up creating a span for each client call, each server handler, every database call to every one of our many databases. And this all starts to add up. All of this insight comes at a cost. So Honeycomb, quite rightfully, charges us per event processed at their back end. And you might end up with a usage page that looks a lot like this one. It's a vicious or maybe a virtuous cycle. So the more value you get out of it, the more services and events you want to wire up, the more events you have, the more value you get out of it, and it just keeps on snowballing from there. But Honeycomb does have an answer for us here. The standard response here is dynamic sampling. Now to explain, I've got a little bit of a diagram. So imagine each of these gray boxes is an event. Without sampling, we'll keep every one of these events that's been produced. The idea with dynamic sampling is to identify events that contain some interesting properties. Maybe we'll keep every event that contains an error, or every event that lasts more than a certain threshold. And then we simply throw the rest away. Now, Honeycomb has a really neat feature here where it keeps track of how many were thrown away, so it can still work out averages, percentiles, things like that. I've never quite understood how it does it, but there's a paper and I trust it, I think. But if we do this naively, we end up with gaps in our distributed traces. We've sampled out some events, but kept others. So we get partial trace. We've lost some of that valuable context of what events caused other events and how these things all related together. But luckily, once again, Honeycomb has an answer for us. The tool here is a tool called Refinery. Now, the idea with Refinery is that instead of having all of our services send their events to Honeycomb directly, we introduce Refinery in between as a buffering proxy. So we deploy it on our own infrastructure, and it will collect up those events it's receiving. It will apply the sampling rules to a whole trace at once, and then it will, if the rules have passed, send that whole bundle of events to Honeycomb. Now that means we don't end up with those gaps in our traces anymore. So to see what that kind of looks like, we take our demonstration model, and then I've just drawn some boxes to represent how these are related into traces. Now, something interesting has happened here. This original diagram, I started with a load of gray boxes and I just colored some in at random to see what that would look like. And then when I applied these boxes around, if you look closely, you'll see that every single one of these boxes has an interesting event in, which means we're going to keep all of those gray boxes that we were going to throw away last time. Now, we're back to keeping all of our data, which is not what we wanted when we introduced this sampling. And the only real way to deal with this is to change our definition of interesting. So we either change the criteria or we decrease the sample rate so that more events are filtered out. And now we have some boxes that are fully gray. And once again, we can throw that away and keep some. So we've now gained the ability to keep traces together. We're not getting those gaps, but we've had to throw a bit more data away, or a bit more interesting data away to get there. So to think about what this looks like as a model, to give an example of what we might end up with if we apply this and think about it carefully. So let's say we keep 1% of all traces, but then we keep 50% of slow traces and 100% of error traces. So this is sort of thing is probably a decent balance between cost and benefit in terms of being able to keep what's probably interesting and throw away what isn't. But what if we want to ask a query something that's orthogonal to what we're sampling on? So for example, how many traces were initiated from bot users? Now the answer that we get from this after Honeycomb has multiplied all those sample rates back together for us will be an estimate. And how accurate that estimate will depend on whether the property, in this case, is it a bot user, whether that's evenly distributed across the axes of sampling, so slow and errors. If, for instance, there's a very, very rarely do bot users produce errors, then we'll get an answer that doesn't quite make sense, maybe, I think. I always find this to be a bit of a mind bender. I can't quite get it to fit in my head and visualize, okay, when I'm asking a question like this and I'm using sampling, how much can I trust my answer? So where have we got to? We've taken those like lovely trace waterfalls that everyone liked and drove all that adoption. But then because of scale and cost issues, which are good problems to have, we've ended up operating in new software components. We're delaying events by holding them in a buffer. We're throwing away a bunch of data, which we hope we didn't need. And in some cases, we're lacking intuition on how trustworthy our query results are. And this is starting to sound a little bit like the setup that we adopted Honeycomb to get away from in the first place. So this talk isn't actually about any of the problems I've just described. That was really just me trying to set the scene. Hopefully some of those things I've talked about ring true with your own experiences of adopting Honeycomb. But anyway, you're now hopefully on the same page as me for the problems I was thinking about. Now, one solution to dealing with these problems is, instead of trying to layer yet more software on, layer yet more complexity on, is to do something quite different, take a real step back. And you might be surprised to hear that before summer 2018, Honeycomb didn't even really support rendering tracers at all, but it was still very useful. So if we don't have tracers, what do we have instead? Events, the single wide events. We get our application and we have it send a bundle of data related to an important business transaction. And I use the term transaction very loosely in a sense, as in a thing. And we send that to Honeycomb in one go. And we keep 100% of these events. If we have other services involved in servicing this transaction, then we get them to pass their information onto the application that's doing the sending. We'll either store that information in memory, or maybe if it's a longer running transaction, we'll put it in a database and pull it back later. And over time, we just keep adding more and more stuff to this bundle of data. It has this almost gravitational pull. And you might notice that looking at this diagram architecturally, this is quite similar to the refinery model from earlier. So the main difference here really is that the arrows along the top tend to be bespoke, or at least in the way we've implemented it. We're not just using standardized tracing protocols. And rather than sending a bundle of events over to Honeycomb, we're just sending the one big one. So this probably sounds a little bit vague, not particularly useful. So let me try and make it a bit more concrete. So at CircleCI, we started sending a single wide event for each task we execute on our system, the task end event. We also have distributed tracing in this part of the system, but this is separate to that in addition. So the tracing is subject to the dynamic sampling and all the problems I described earlier, whereas this one, we keep 100% of them. And we don't set a trace ID, so it doesn't participate in the trace. But there's still enough context here with the build ID and the build URL to match them up to traces if we did keep a trace for some reason. Now, executing tasks is the core part of what our product does, and it's what we charge people for. So any costs we incur from keeping 100% of these events is directly proportional to revenue that we're charging to customers. And that's really effective. It means we don't have to worry about, can we afford to keep all of these? So we know we can, because there's just one, and we're charging, this is part of our like core revenue stream. And so we keep a load of facets about the build, like what sort of executor did it run on, how long did it take to run, how long did it queue, did it pass, and a load of environmental factors like where did it run, which availability zone, what versions of things, and so on. Really anything we can come up with that we think is useful. And we've kept adding to this over time. The more we use it, the more we think, oh yeah, this would be handy. And this allows us, with just a single event, to answer a whole lot of questions. So for example, we deployed a canary on a particular AMI, and then we say, okay, let's have a look at any customer builds that failed on that particular version. Would they normally have failed? Did they fail because we'd done something wrong, or did they just fail because it's a standard test failure? And we're able to pull that out really quickly and dig in. We had a report from another customer saying they were experiencing some surprising slowness. So we were able to use their build URL, filter by their events and see, okay, yeah, they hit an infrastructure failure, but this wasn't a widespread issue. It wasn't affecting loads of other customers. It was just this one person. A few months back, there was a Docker Hub outage. So Docker Hub was in a partial state of failure for a good sort of hour or so. And we can see quite clearly on this graph that that's really caused our overall build success rate to take a big hit. And it did come back again pretty steadily afterwards. And that was really easy to see on this graph very quickly. Recently, we made some changes to the checkout step. So when you do a Git checkout, and when we canaried that, we were able to do a side-by-side comparison over the course of a few days here, I think it is here. And we can see that, yes, we did improve tail latencies by a significant amount. And this is all using the same event. We can also answer some slightly more business product-focused questions. So we launched a new ARM-based executor using the ARM CPUs. And we could use this same event to track which customers are using that event, using that executor. Like, what sorts of things are they running on? Can I go see their builds? Another thing we did recently was like, how much data are customers storing using our built-in S3-based steps. So this is like when you store caches, workspaces, artifacts, and interesting. And like, how do customers compare to each other? Are a few customers doing all of the data storage, or is it fairly even? And we were able to identify some outliers and reach out to those customers and say, help them optimize. And this is, once again, just bundling more and more fields into that same event and then getting used to slicing and dicing against it. There's been an uptick recently in crypto mining across a number of CI platforms. And once again, we could use this event to say, are there any suspicious looking builds that, I don't know, run for a long time or use loads of CPU that we can then dig into and say, are they legit or not? Let me do a worked example of something a bit more involved. So a couple of months ago, we have this concept in Circle called an infrastructure failure. And basically this is a build failed and it was CircleCI's fault, not your fault. And we saw this big spike in infrastructure failures with a category of unhandled prepare executor error. So in the process of preparing an executor, something went wrong and we got this spike. Now we can pull up a heat map. So what I have here is a heat map showing a 0, there was no infrastructure failure, and a 1 for yes, there was an infrastructure failure. And then using the bubble up tab, I can draw a little box around it. Honeycomb will highlight anything that's interesting about that box. So I go look at the facets here. So basically the yellow bar is things that were inside my box, and the blue bars are things that were outside my box. And the first couple of rows here are basically various different ways of saying, yes, that did fail. That failed for infrastructure failure. However, the first interesting one is really that bottom right one there, which is the executor. And it's this event was able to show us that 95% of all of those failures were happening on the Mac OS. And after a bit more investigation, we were able to identify there was a networking issue with our Mac OS data center provider. We got in touch with them. And so while our Mac OS team was liaising with them, we were then able to use this same event to get a list of affected customers. So we modify the query slightly and say, okay, give me every build URL where it was executed on Mac OS and there was an infrastructure failure. And ta-da, I've got a list of affected customers that I can hand off to the support team, and they can do some proactive outreach, or at least they can be prepared when tickets come in from these customers. Now, I use the term single because they're not part of a big trace. They're not connected to a whole lot of other events, but that doesn't necessarily mean we're only allowed one event per transaction. We can have as many events as we deem worthwhile. And if we tie them to important actions in our system, it's easy to predict how many we'll get and therefore how many will cost. When you're dealing with traces, it's quite difficult to think, okay, I've got one request. How many sub-spans is that going to create as it ripples its way through our microservice system? It's quite hard to predict ahead of time. Whereas when I'm dealing with these single events, it's very easy to go, okay, I get 10,000 registrations, and that's a lot. I get 100 registrations a day, therefore I'll get 100 of these events. And that's something that's quite easy to predict, and it's really good for when you're trying to model like how much you're going to pay Honeycomb and how much you're going to pay the next month. So that task end event has an associated task start event, which is like how long has a build queued for. So we've got two events happening from that same transaction at different parts of its life cycle, but still like it's 2n. It's not going to grow logarithmically as our system scales. Another event we added into our system is the Docker pull event. So each time our core system does a Docker pull on behalf of a customer, we store an event. Now, a single task can have 0 or many Docker pulls, so that's why we couldn't just stuff them into that task end event. If you use like the machine executor, for example, then you won't have any Docker pulls that we do for you. Whereas if you make use of our secondary containers to run databases, you can run 2, 3, 4, 5 additional containers alongside your primary container next to your tests. The other reason not to put this into the existing task end event is that task end only happens when a task finishes. So if a task is going to run for like 5, 10, 15 minutes, we want to release some of that information earlier. So if we're seeing some errors around Docker pulls, this event will show those up much sooner than if we're buffering them. And that's also a situation you can run into with Refinery, where it's buffering stuff up until the trace finishes. But if those traces are taking a while to complete, then you're not seeing any of the events from at the start of that buffer. Now, once again, although similar to the task end event, this isn't connected to the trace graph, but I do have enough fields on here that we can make that link directly. One thing we've been meaning to look at for a while is using, I think they're called event links. There's some sort of feature in OpenTelemetry that allows you to link one event to another without making it part of a trace. That's not something we've explored yet. But as well as the which build is this from, we also store information about the image, the registry, how long did it take to pull, which is generally proportional to network issues, and then how long did it take to extract. So Docker images get downloaded as tarballs, which then have to be unpacked. And that is dependent on CPU and disk speed, so that can highlight a bunch of different issues. And then, as before, we store a whole bunch of information around the environments, like the resource class, the instance availability zone, and the versions of all the bits of software that were involved, so we can hopefully give Bubble Up plenty of juicy stuff it can facet against. And once again, this allows us to answer a whole bunch of different questions. We initially did this work to help support some stuff we were doing around Docker startup performance. So we'd seen a steady increase in basically complaints from customers about builds taking a long time to start up. And this event allowed us to really nail down where that was coming from and why. And then as we made changes and launched Canary versions, we could see the impact on this event. And then shortly after we'd added it, Docker announced that they were going to start rate limiting pulls on unauthenticated builds. And that affected quite a lot of customers. We were able to put together a partnership with Docker to handle the majority of cases, but we were still had a few customers that were affected, and this event highlighted those directly and allowed us to reach out. Later, we then added a field, we looked at that field for download speed, and we were basically trying to say, okay, how do we speed up downloads on our system? But then we just almost took a step back and said, okay, well, why are downloads slow? And the insight we had here was we made a derived field for the registry, which also included the AWS region. And we discovered that a number of customers in the Asia Pacific AWS regions were affecting our SLI because they were pulling, and the AWS network speeds really drop off significantly. So if you're in the same data center, you get 100 megabits per second. If you're in the other side of the US, you drop down to 20. And if you go out to Asia, you're down to 5 megabits per second, which is a huge drop off. And so then we were faced with this question. So this is affecting our SLI, and we could just exclude these events from our SLI and go, ta-da, our number's better, but that's not really improving the customer experience. So maybe this is a docs problem. Maybe we should be being more forceful about saying, hey, you're pulling from a region that's really inefficient, like warning, maybe you should do something else about this. The other interesting thing about this data, which I still can't quite get my head around, is that if you do a Docker pull from AWS, where the source image is in Google's container registry, that is somehow faster than pulling it from the AWS region you're in. And I still can't explain that. Anyway, so in conclusion, distributed tracing is really great. I love distributed tracing. However, a single wide event can answer a lot of questions. And when you tie them to business transactions, they can be extremely cost effective. You're knowing, okay, here is a revenue generating event, and I'm storing one thing at a time and paying the very small per event charge. Keeping 100% of those events should be easy to reason about. Whereas when you're trying to deal with like dynamic call graphs of distributed tracing, that's a lot harder to get your head around. But the key thing here really is that everything is a trade-off. In an ideal world, we simply keep every single event in every single trace. And if you're at the scale where you can afford to keep every single event in every single trace, then I really recommend you do that instead of anything I've talked about today. But that's unlikely to be viable for any system with significant traffic. And the strategy I've laid out today is mostly driven by Honeycomb currently works and currently charges. So maybe in future, as Honeycomb adds more features or different approaches become viable, then we'll be able to make different trade-offs. So this is what I've got today. Well, thank you very much. I've been Glen Mailer, and if you have any questions, now's the time.
Hey, let's give it up for Glen. Thank you, Glen. That was great.
Thank you for having me.
I really loved that approach and how it like plays to the strengths of Honeycomb and our platform and how it works and like manages the costs, but like still gives you all that power, especially like Bubble Up is just really shines in that use case. I'm curious though, like you said that there is tracing in other places or other areas. Like what do you see as the trade-off between the two? Like when would you pick up tracing versus this approach?
I think fundamentally it's really just cost. Like, and this is kind of like what leads people to tracing in the first place. Like your metrics are costing you way too much, or your logs are costing you way too much. Like you're at web scale and you've got terabytes of logs a week, and you're finding some way to handle this. And I think kind of what I came back to at the end was there is no universal correct answer, apart from like if you've got infinite storage somewhere. So yeah, you have to pick the trade-off depending on what you're trying to do at any one time. So if you can, I think the key thing was I said when it's related to a business transaction, like when it's something really important. So like you probably don't want a single wide event 100% sampled for every API call, but you probably do want one for every login or every registration, certainly. So yeah, I guess to take your Honeycomb as a product example, you probably don't have that many of these because it's a very sort of like lots of small transaction type of system. Whereas in CircleCI, like we run a lot of builds, we ran a lot of builds, like millions a week, but that's not actually that much when you turn it into a per second number.
Yeah. No, I love that idea of tracking it back to business, right? We're always here to like make the business value, like have this connected back to actually, being here for what we're trying to do is serving customers and making business. So that makes a ton of sense. Can remind people to drop Q&A in the Slack channel if they've got. I'm hoping for more Q&A. Yeah. I don't know if I've got others off the top of my head.
The interesting thing for us is it was that I don't know if I had this picture in my mind when I was putting the slides together of this graph where like a bit like that Monzo diagram where you've got all these calls related together, and you're like, it's a bit like the old Joe Armstrong quote where you're like, you want a banana, but you get the banana connects to the gorilla, connects to everything else. Like, okay, I want this little bit of information, but because it's in a trace graph that's connected to hundreds of other traces, then you've got to keep all of it because that's the way the system's wired up. And so there's I think there's a middle ground between these two things, which I really want to investigate more. There's a guy on the Honeycomb Slack called Pedro from CarWow, and he talked about this once. But this idea of so at the moment, dynamic sampling, and I think this came from like the open census and open tracing communities. They're very much, you keep a whole trace or you throw away a whole trace. And I really like this idea of what if I have like half a trace on purpose? Like what if I keep the top level span from all of the services that were involved, but none of the subspans, but then on like 10% of traces, I get the full fat, I get the big ones, and just what other axes can we sample against other than just like keep a whole trace or not a whole trace? And I think there's so much to explore in that space.
Yeah, no, that is really fascinating, right? That you've got this, right? I don't know how to like separate it, but like at the edge of each service, you've got something higher value, and then in between, maybe you turn that on when you've got a performance issue and need to see the smaller grain steps, but you can filter that out at different times too.
Yeah. And each step has like a different level of cost. There's like, okay, I'm storing it in memory for the duration of my request. Well, that's pretty cheap. I mean, it's not entirely cheap, it costs memory. But then you're like, okay, well, now I'm sending it to my collector, and maybe I'm sending it to the collector on my node. And then maybe I'm sending it to like my refinery and my cluster deployment that's going to bundle it all together. And then I'm going to send it to Honeycomb. And maybe like Honeycomb can throw some away later. Like old refinery product was in that space. Like there's lots of different, each step has an additional cost, but also gives you more things to look at once.
Right.
So, okay, well, I'm going to trace every single database call, but I only care about seeing all my database calls when I've got a slow request, maybe.
Right. Totally. to skip to a different idea, you'd said in one of the threads in Slack already, said if you enable JSON unpacking and accidentally send something huge, you can get some really fun results. I'd love to know about the fun results.
So this wasn't actually me. So this was just me hanging around Honeycomb Slack, and somebody came in one time and was like, "I'm getting like a rejected payload from your API," and then after some digging, it turned out they'd had like a really deeply nested JSON object with, I think maybe the unpacking unpacks arrays as well, so like 100 web requests or something. So yeah, it blew the 10K field limit, which I think doesn't happen very often, is my understanding.
Yeah, that's great. Got a question here. You drank the Kool-Aid, but when did you take the first sip? How did you discover Honeycomb? What problems were you trying to solve?
It's a really good question. So I think the thing that really got me hooked was at Circle, where we had these sort of fairly infrequent but like this. We do a lot of builds, but they don't happen like, it's not like hundreds a second. It's and they all come through the same pipe, and they all look completely different. And so this perfect high cardinality example. But I think I'd got interested in Honeycomb for like a couple of years before that. I've been following the company since it was quite early, and I think part of that is what's led me to stick to this wide event thinking, because I say, like, I used Honeycomb, or at least I watched some Honeycomb videos and tried some demos before you had tracing support, when it was just all you had was events, and you could look at one event at a time, and that's, that better be good enough. And it was still really powerful with only that. And I think in this sort of the excitement to jump on the tracing bandwagon and get involved in tracing, I think they've lost the fact that actually it worked really well before tracing.
Yeah. And then to follow on that, like, how did you get to this, like this particular use case here, right? Like, because again, going back, you had said that there is tracing. So like, what drove you here?
Yeah, I think it's sort of like we had a structured log that did something similar. And it just wasn't as easy to query, because it was we were using like a self-hosted Graylog, and it was very expensive, and we couldn't index things, and it treated everything as a string because there was some Java interface it went through in between that only had map of string. So yeah, like I think Honeycomb was a chance to give us a fresh start and like design our logs from scratch in a way that like indexes on the things we care about. And we basically just wrote some custom code to say, okay, here is exactly what we want to do. We're not going to use we use the beeline at the end, but we're not like, there's no auto instrumentation. There's no like, ta-da, just sprinkle it over here. There's just like, I'm going to think about my application. I'm going to make a map of string to stuff, and I'm going to send it to Honeycomb, and then I'm going to get it back out the other end later.
Yeah. And so then a question on that is, how did, this person said they might have missed it, but how did you instrument your code to actually get the data out, like the events out, to make that major one single event?
So we generally we'd sort of have an implementation where there's like a per request, like singleton almost, that is a map. And then throughout the code, there's like the abstraction allows us to just bundle stuff into that and then flush it at the end. And then in a few places where there's like cross-service boundaries, we've just got like custom implementations in each spot to say, okay, well, here's some data, do what you want with it. And then the service at the end like bundles it all together. And through that, we're able to grab like tags from AWS, and we're able to grab the results of the build and the inputs and all these sorts of things. And just, so it's not like, it's like the opposite of OpenTelemetry almost, but it's, it's really powerful.
Nice. Well, thank you, Glenn. We're going to wrap up here.